In this video, I'm going to look at similar shapes, and we shall look at relationships between similar shapes. So in the figure below, shape A dash is an enlargement of shape A. Now here, if you remember what we discussed about enlargement, you know that you have the center of enlargement, you have the object, and then the image. So the image here is A dash. The object is A. Now, there's some few things here that we can remind ourselves based on what we discussed when we look at enlargement. So the first point is that the lengths of each side in shape A dash are actually twice the length of each side in shape A. What that means is, for example, here, this length here is 3. This length here is 6. This length here is 2. That length there, from here all the way to that point, is 4. So if you notice here, the length of the image are twice the length of the object. So we can say that the object has been enlarged by a scale factor of 2. Now 2 here can also be called a linear scale factor. It's still a scale factor, but it has to do with the length, so we call it a linear scale factor, which is basically the ratio of the two corresponding sides. For example, you can notice that. So notice that the ratio of the sides are equal. Like for example, 6 divided by 3 for these two corresponding sides will be equal to 4 divided by 2. And this will be equal to, so we have the same ratio, which is basically the scale factor in this case. And what I'm saying is that this is also called the linear scale factor. Yeah. So basically notice here that by looking at corresponding lengths, we can be able to find the linear scale factor. Okay, so let's see how we can apply this in some problems. So in number 1, explain why these triangles are similar. Now basically what you have to do first is look at the corresponding lengths. So that length there corresponds to that, and maybe that length there corresponds to that. Yeah. So basically what we can do in this case is well, the question is explain why they are similar. So we know that for triangles to be similar, they have to have the same scale factor. Yeah, they have to have the same linear scale factor. And how do we find the same linear scale factor? By looking at the ratio of the corresponding sides. So one, we can say that oops, sorry. So we can say that the ratio of corresponding sides are equal, and we'll check that. So the ratio of the corresponding sides are equal. All right. So we can check that statement by looking at corresponding sides. So notice here that PR over now PR corresponds to this length, which is AC. That is equal to 18 over 6, which is equals to 3. Another thing we can also notice is that PQ which is basically this length corresponds to AB. So PQ over AB should have the same ratio, but let's check. So that will be equal to 15 over 5, which will be equal to 3. Now you can see that we have the same linear scale factor. And because we have the same linear scale factor, then that implies that these two triangles are similar. Of course, another thing, you can also say that angle P is equals to angle A. Angle P is equal to angle A. Now, one thing with similar shapes is that the corresponding angles will be equal, but of course their sizes will be different. All right, so give the ratios of the sides. So the ratio of the side is 3, and then which angle corresponds to angle C. So we can see that angle C corresponds to that, and angle B corresponds to that. Actually, let me add that. So basically, the angle that corresponds to C is R. So you can say that's angle R. And then which side corresponds to QP? So QP, that will be BA or AB. Okay, number 2. So in number 2, explain why these triangles are similar. Again, it's just the same as what we've just discussed. You have to look at the ratio of corresponding sides. So 1, by looking at the ratio, we can just say ratio of corresponding sides are equal. And I'm going to show that. So you can notice here that QR corresponds to BC. Now QR is 9, BC is 6. So that will give us 1.5. Let's pick two other sides that correspond to each other. So if you pick PR, which is this one, it corresponds to AC. Now notice that PR is 7.5 and AC is 5, and this will be equal to 1.5, and you can see that this is equal. Yeah, so these two triangles are similar, and you can just add one more statement, number 2, and say that um, two corresponding angles are equal, and because two corresponding angles equal and other sides are in the same ratio, then it will imply that the two triangles are similar. So we can say that angle C is equal to angle R. So angle C is equal to angle R. All right, let's proceed. So next question here is um, which angle corresponds to A? So A, of course, that will be, so this corresponds with that, and this corresponds with that. So that will be angle P. And then which side corresponds to SC? That will be SC, that will be PR. Okay, number 3. Explain why triangle ABC is similar to AQR. Now, what you can do in this case is you can sketch the two triangles because you have one inside the other. So break them apart to break them apart. So you have the smaller one, and then this is just to help you visualize. Okay, so 90 degrees. The smaller one is ACB, and the bigger one is ARQ. Obviously, this angle here applies to both, so this angle will be equal to that. But again, another thing is this angle here will be the same as that. Yeah, so those two angles will be equal. So this angle here will be the same as that. Yeah, because it's a right angle triangle. So um, if you enlarge, just think about it. If you enlarge a right angle triangle, you'll end up with a right angle triangle. Anyway, so moving on, we can now plug in the lengths. So basically, AC is 5 centimeters, AR 7.5, um, PC it's 6, and then QR is 9. So the first part is explain why triangle ABC is similar to that. So we just need to show that the ratio of the corresponding sides are equal. So the ratio of corresponding sides are equal. And how do we do that? We can go ahead and pick two corresponding sides. So we can pick, for example, uh, we need to show that um, QR over BC should be equal to AR over AC. Yeah, and we can check QR is 9, BC is 6, and that should be equal to 7.5 over 5. And if you divide each of these, the answer will be 1.5. So basically, the ratio of the corresponding sides are equal, hence these two triangles are similar. And then the next question is, which angle corresponds to angle B? So angle B, of course, we can see that that will be angle Q. And then which side of triangle AQR corresponds to side AC um, of triangle ABC? Um, so which side of this big triangle corresponds to AC on the small triangle, and that will be AR. So AR.